Hey, this video is going to cover TypeScript, what it is, how to use it with function and interface examples, plus how to run the compiler to use it in your project. So what is TypeScript? TypeScript was actually developed by Microsoft back in 2012. You can think of it as an add-on to JavaScript. In general, it adds the ability to define types in your JavaScript code. In regular JavaScript, you can define a variable and assign it a number. But if you accidentally tried to do a string function to it later on, like convert it to uppercase, it would throw an error. But this error wouldn't show up until that bit of code was ran, which could be minutes, hours, or even weeks after people start using your site. With TypeScript, you'd see an error immediately in your code editor as soon as you typed the toUpperCase function. And that's if the editor has a TypeScript checking functionality, of course. Or at the very least, you'd see the error when you run the code to transpile the TypeScript into JavaScript. So what does that mean? Well, right before you're ready to make your code live, you'd run a command to convert or transpile the TypeScript into regular JavaScript. So in the end, there's nothing really fancy or new going on with the finished web files. TypeScript's whole reason for existing beforehand is to help you remove errors in your code before it goes live and to help you code faster. First thing you need to do is install it as an NPM package. If you don't have Node.js and NPM set up on your computer or your project yet, I'll have another video on how to do that. But if you do, you just simply run npm install TypeScript. Also, if you have a code editor with TypeScript or ESLint add-ons, it'll help enable those. Here in Visual Studio Code, TypeScript is supported by default, and you can also add the Microsoft ESLint extension to have the editor check the code while writing it. Now you just need to write some TypeScript files, so let's go over the syntax. TypeScript files end in .ts instead of .js, and you can easily just rename your existing files if you have them. If you want anything to be checked by TypeScript, you need to start specifying types in your JavaScript code. So to do that, instead of writing let age equals 39, you could instead type let age :number equals 39. The colon after the variable name is where you start declaring what type of variable it'll be. There's primitive types like string, number, boolean, and so on. But you can also define custom types like user or order or cart, as you'll see later on. Another neat thing though is that you don't have to declare the types if it's obvious. TypeScript will infer the type, like this example, with a string instead. And that also means we can get rid of the number type in our first example. Notice how it knows the types when you hover over it in VS Code. And to show the benefits of doing this, as you've already seen, we could try to lowercase our number, and we immediately get an error in the code editor. We can also try to incorrectly assign a number to our string variable and also get an error. These errors wouldn't show up in normal JavaScript until it's too late. Some more complex things we can do with this is define a variable as being more than one type. So we can have a variable that is a number or a string, like this. Or probably more commonly, undefined or something else. This pipe character that we use is called the union operator. We can also use this to limit the values to a certain preset list. So we can define our own types with the type keyword. So say we have a variable for what button types are valid for a button element. We would define it like this. And we can separate the possible values with the union operator. And then we can create a variable later on that will have that type. And notice if we somehow try to set this value to something not in the type list, it'll throw an error. Plus, as we're starting to type the correct value, we are presented with an autofill list we can pick from, which I think is pretty awesome. TypeScript will also catch pretty common mistakes, like typing a variable name incorrectly. This example wouldn't throw an error in your IDE, usually, but it does here. Types can also be set in function parameters. Let's say we have a helper function for doing an API request. And in the parameters, we can say we need a URL, which will be a string, a method, which will be a string, and a data variable, which will be an object. Notice to add types here, it's again just a colon and a type after the variable name. In the API function, we can call a fetch function and fill in the URL and options like this. Also, we can provide defaults to our parameters. GET requests are usually pretty simple and don't require sending data in the body. So we can say that the default method for this function will always be GET, and the default for data will be a blank object. Now someone can simply call a get endpoint with only the URL. We can also call a delete API call with the same function by specifying the method now and the data to be sent. Notice another really helpful thing with TypeScript, which are these autocomplete hints while we're filling in the arguments. The editor knows that the second argument in our function is a method, and it tells us the third is going to be an object. This might not be as handy when the function is right below and we can see it, but most of the time that's not going to be the case. In our API function, we can also use TypeScript to specify what type of data is sent back, if any, and this will be the return type. To declare a return type, you do a colon and the type after the parameters, parentheses. So here, the return would be a promise, since it's an async function, and the promise returns void in this example. And we type that using the generics syntax, which is the angle brackets. In an API call, though, it'll likely return void or perhaps a JSON response. We can define this as well with TypeScript with the union operator again. This is saying it'll return a promise that is an object or void. Now we just need to modify our code to actually return that object. And if we go back to our get API call up above and assign the result to a variable, we can hover over that variable and see that type will either be an object or void. And if we need to do an if statement to check if the result is not void or undefined like this, inside the if statement, the tooltip now knows this variable is for sure an object at this point. An interface is another powerful thing in TypeScript that I use constantly. An interface is basically a blueprint of what a specific object will look like. For example, I usually create a matching interface for every table in my database if my app is interacting with the database. So say your app has a shopping cart. You'd make a cart items interface and define the properties an item in a cart would have. And for each property, you would say what type it would be after the colon. And then we can also have an interface for the cart itself. Notice here the JavaScript date object is a valid type we can use. And for the cart items property, that will be special. We can say the type for this one is going to be an array of our cart items. Your interface has now become a user-defined type that you can assign anywhere, just like our primitive types. The square braces after the type just means it'll be an array, and you can make any type an array using this. Now to use our interfaces, we'd somehow create an object for it. So let's have a new variable called cart, and then we would make it a cart type by doing colon cart. And if we leave it blank for now, our TypeScript linter will yell at us saying that we're missing the required properties. So we're forced to fill in these because of TypeScript. You'll never forget or miss a property now if you use this for all your objects in your code. Notice the autofill working for us too because of the TypeScript. Our created date has to be a JavaScript date. We can't accidentally or purposely supply a date string like this. And our list of cart items for now can just be a blank array. Properties in interfaces can also be optional. So we can add a new property for a coupon code to our cart interface and put a question mark after the name to say it's optional. And since it's optional, our cart object below won't throw an error because it's missing. Functions can also take in and return these special types now. So say we have a function for adding an item to a cart. You provide an item ID, the quantity, and a cart object, and it'll return the updated cart back. Again, to declare a return type, you do a colon and the type after the parameters. You probably take that item ID and get the description and price from a database, and then you just fill in a new cart item object with it. Then we can just push the new item to the cart array and send it back. Now that this is added, if we would have failed to send back a cart item here, we'd also get a big nasty error from TypeScript. To use this function, it would look something like this. And since we already have a cart object above, we can just send that at the end. Again, see how the autofill is helping us as we type? And notice if we hover over this new cart object, it already knows it's a cart type. We don't have to define it with the colon cart. That is because of the return type we just added to that function. Plus, if we try to use this object later, our autofill will work the way we expect for cart types. Also, if we tried to reference a property that doesn't exist on accident, we'd get an error. Once you have all your JavaScript all ready to go, we can take your TS files and create JS files from them by running the command npx tsc followed by the file name, or a list of files. But your project will likely have multiple TS files, so instead, we can tell the compiler to convert multiple files or a whole folder using a tsconfig.json file in the root of your project. This file, in my example, will have some extra settings to specify what ECMA script version we're using, and we're just going to say whatever the next newest one is. And we need access to the dong functions as well, which gives us access to console and fetch. Then we can also tell it to include anything in the JS folder, for example, and exclude nothing. And here you can exclude specific files if you needed to, of course. Once you have this config file, you can run npx tsc without any arguments, and it'll just create matching JS files for any TS files in our include array. If we look at our script.js file it generated, here's what it looks like if you're interested. And now you would just go into your HTML and include this JS file like you would normally would. And that's about it for the basics. Again, you can take any existing JS file and make it into a TS file, and then slowly add types as you wish. There's no need to convert everything all at once if you don't have the time for it. If you have any questions about this, just let me know in the comments, and thanks for watching.